Determinant of 2 by 2 matrices. Given A is 2 by 2 matrix, then determinant A is denoted in this form and defined as AD minus BC. Given matrix A and matrix B, find determinant A, determinant B, and determinant AB. First, find determinant A. Write matrix A in determinant form. Then, by using AD minus BC, so 2 times 8 minus 5 times 3, and determinant A is equals to 1. Next, find determinant B. So write in determinant form by using AD minus BC. So 3 times 2 minus 2 times 5, and determinant B is equals to negative 4. How to find determinant AB? First, find matrix AB by multiplying both matrices. We already discussed the multiplication of two matrices in lecture 1. So here is matrix AB. Then write matrix AB in determinant form. By using AD minus BC, we have 31 times 22 and minus 14 times 49. So determinant of AB is equals to negative 4. Minor and cofactor. Let A be n by n matrix. Then the minor, we use capital letter of M of element I row j column of the element I row j column is the determinant of the matrix obtained by deleting the I row and j column of A. Consider the matrix A. Then the minor of element row 1 column 1 is the determinant of the matrix obtained by deleting the first row and first column from A. Now we have minor of element row 1 and column 1. So write in determinant form. Then delete first row and first column. So we have determinant 4, 2, 4, 3. Then by using the formula AD minus BC, we have 4 times 3 minus 2 times 4, and minor of element row 1 column 1 is equals to 4. Similarly to the minor of element row 3 column 2. First, write in the form of determinant, then delete third row and second column. So we have determinant 1, negative 1, 3 and 2, and use the formula AD minus BC. So we have 1 times 2 minus negative 1 times 3, and then the answer for the answer for minor is equals to 5. As a conclusion, if we have matrix A, 3 by 3 matrix, then minor of element row 1 and column 1 and minor of element row 3 and column 2 is given as follows. Cofactor. The cofactor of element I row j column is negative 1 to the power I plus j times its minor. Look at the example of cofactor of element row 1 column 1. Substitute into the formula negative 1 to the power 1 plus 1. That means the element is from first row and first column times its minor. So the answer is 4. Cofactor of element third row second column. Substitute. So we have negative 1 to the power 3 plus 2. So the order of the element is third row and second column times its minor, and we have negative 5. As a conclusion, the cofactor of an element is the minor that element multiplied by 1 if I plus j is even, or negative 1 if I plus j is odd. Example 2. Given matrix A, find the minor of matrix A and find the cofactor. Here is the minor of matrix A, but how to get this form? Remember, minor is the determinant of the matrix obtained by deleting its row and column. Look at the element of row 1, column 1. So, to find its minor, delete its row and column. Refer to matrix A. Then, the minor of element row 1, column 1, we have to delete its row and column, then write the resulting determinant. Okay, for the element of row 1, column 2, delete first row and second column, then we will get this determinant. Next, for the element of row 1, column 3, so delete first row and column 3, so we will get this determinant. Next, for the element of row 2, column 1, delete its row and column, then write the determinant. For the element of row 2, column 2, you have to delete second row and second column, then write the resulting determinant. Okay, next, for the element of row 2, column 3, and again delete second row and third column, and do it the same way for element of row 3, column 1, and then for the element of row 3, column 2. Okay, then for the last element of row 3, column 3, so we will get this determinant. Okay, next, solve the minor of matrix A. So by using AD minus BC, then we get 0 times negative 3 minus 4 times 3 for the first element, and then for the second element of row 1, we will have negative 2 times negative 3 minus 4 times 4, and for the element of row 1, column 3, we will have negative 2 times 3 minus 0 times 0 times 4. And apply the same way to the each element in matrix A. Then the minor of matrix A is as follows. To find the cofactor of matrix A, use the form of negative 1 to the power I row plus j column times its minor. So this is the minor of matrix A. Then cofactor of A is given as follows. To get the cofactor of element row 1, column 1, substitute into the form. So we have negative 1 to the power row 1 plus column 1 times its minor. Then the cofactor is negative 12. For the element of row 1, column 2, then we will get negative 1 to the power row 1 plus column 2 times its minor. So the cofactor of A become 10. Then for the element of row 1, column 3, then write as negative 1 to the power row 1 plus column 3 times its minor. Then the cofactor A should be negative 6. for the element of second row, first column, substitute into the form -1 to the power row 2 plus column 1 times its cofactor. Sorry, it's minor. Then the cofactor is -18. So apply the same way for the next element. Okay. Then so we have 2, and then for the element of row 2 column 3, we will get the cofactor of -22. Next, for the element of third row and first column, so the cofactor is -16. And for the element of row 3 and column 2, the cofactor will be -4, and the last cofactor is -8.